So good morning to all of you. So today we are going to start the next unit of your subject operating system. The unit number 5, that is input, output and file management. So in this particular unit, we have to see or we have discussed about IO management, the disk scheduling, the first point. So in that IO devices, organization of the IO function, the operating system design issues and the IO buffering. And the most important part of this particular unit, fifth unit, that is nothing but the disk scheduling algorithms that we have to discuss here. First in, first out, SSTF, that is shortest seek time first, scan algorithm, C-scan algorithm, look and C-look algorithm, and finally disk cache. And this file management is the last topic from unit number 5. In this file management, we are going to see the overview of the file management, how the files are organized and accessed, the file directories, file sharing, and the record blocking, and the secondary storage management. So this entirely comprises of your unit number 5. So let us start one by one point here. Introduction to secondary memory. Now, what is the difference between the primary memory and the secondary memory? Right. So primary memory. So up till now, in the previous unit, we have discussed about the primary memory. So primary memory, it is also called as the main memory, or it is nothing but your volatile memory. Right. The primary memory has limited storage. So you know that. So we have limited amount of primary storage available. For example, 0 to 1 GB of memory or 0 to 2 GB of 2 GB RAM is available. But this capacity is very small as compared to the number of processes available in the system. And it is volatile. No doubt, if you switch off your machine, the whatever may be the data, whatever may be the information loaded in the primary memory, that get vanished. Right. So it is a volatile in nature. Means no permanent storage is provided by your primary memory. So secondary memory overcomes this limitation by providing the permanent storage of data, and it is in a bulk quantity. So secondary storage, often it is called as a disk storage, or it is also called as a hard disk storage. Or secondary storage means any media which can store your data or information for permanently. We can say it means where you can take your USB pen drive as a secondary storage media, or you can even refer CD or DVD also as a secondary storage, where you can store your data permanently and it can be retrieved as and when required. Right. So secondary memory, it is also termed as external memory and refers to the various storage media on which a computer can store data and the programs. The secondary storage media can be fixed or removable. Right. So it can be fixed means just like your secondary hard disk device, it can be fixed, or it is removable means you can have your pen drive, you can have your floppy disk. So in earlier days, the floppy disk was used. Then the fixed storage media, it is an internal storage medium like your hard disk that is fixed inside the computer, whereas the storage medium that are portable and can be taken outside the computer are termed as a removable storage media. Means the secondary storage, it can be partitioned, you can divide into two parts like your removable as well as in fixed storage. So fixed storage, consider it is nothing but your hard disk. It is fixed inside your CPU or inside your cabinet. You cannot remove this hard disk. But your removable storage media like your pen drive, it is a removable one. You can plug and play that particular, and you can store the data. You have the 2 GB, 4 GB, 16 GB pen drive available nowadays. Right? Or you can take the example of your CD or DVD. You can write the data on your DVD. You can play the data through that particular DVD. Right. The next point is uses of secondary media. So the secondary storage media, it is basically used for the permanent storage. So secondary memory or the secondary media, it is the very first use. It is nothing but for permanent storage. Means just like your primary memory or the RAM memory, where data cannot be stored permanently. But in case of your secondary storage media, the permanent storage is available. Permanent storage is available to the data. Means primary memory is volatile. That is, it loses all information when the electricity is turned off. So in order to secure the data permanently in the device, secondary storage devices are needed. So the very basic use or very important use of the secondary storage is nothing but permanent storage of the data or the permanent storage of the information. which is not in the case of your primary memory. So two major important point is that in case of primary memory, it is volatile in nature, no permanent storage is provided by your primary memory. And second point is that it is very the size of the primary memory is very less, right? We have only available 4 GB of RAM, or even we can have 8 GB of RAM. Means there are restriction on the size, or how there are restriction on the size to of that particular primary memory. But in the secondary memory, there is no restriction on the size, or there is no restriction on the storage. You can increase the storage as much you can, it is possible. And portability means the storage medium like CDs or flash drives can be used to transfer data from one device to another device. Means you can transfer data from one location to the another location. So again, it is categorized into two parts. That is nothing but your fixed storage and the removable storage. The first, fixed storage. So fixed storage means what? So fixed storage, it is an internal media. It is internal media device that is used by a computer system to store the data, and usually these are referred to as the fixed disk drives or the hard drives. So the types of fixed disks are nothing but your SSD and HDD. HDD means your hard disk drive, and SSD means solid state units. Right. So your secondary storage, it is divided into the first part, that is nothing but your fixed storage, and second is nothing but your removable storage. So in case of your fixed storage means which is internal to your machine, which is internal to the computer, and it can be further have two types, that is nothing but your SSD as well as HDD, hard disk drive. Right. The removable storage. Removable storage means the removable storage, it is an external media device that is used by a computer system to store the data, and usually these are referred to as removable disk drives or the external drives. Or the external drives means your CD, your floppy, your DVD, your pen drive, all these media, yes, these are nothing but your storage media, and all these storage media are called as a removable storage media, or it is again it is a part of your secondary memory. Hence your USB, it is also called as a secondary memory, but it is in a removable in nature. Your HDD or SDD means solid state disk or hard disk drive, they are also called as a secondary storage, but they are of the type of fixed storage, right? There are following main types of storage media. So again, the further, depending upon their type, they are further categorized into magnetic storage type as well as the optical storage type. Storage type means how the data is being stored on that particular media. It categorizes this media into two categories. That is magnetic storage media, the first one, and the second one is nothing but your optical storage media. Now the magnetic storage media means what? The magnetic media is coated with a magnetic layer which is magnetized in a clockwise or anti-clockwise direction, right? So magnetic storage media, your SSD or secondary storage hard disk is nothing but your magnetic storage device, where it uses a magnetic layer which is magnetized in a clockwise direction or anti-clockwise direction. So when the disk moves, the head interprets the data stored at a specific location in a binary zeros and one at the time of reading. For example, your hard disk, floppy disk, as well as the magnetic tape, these are the examples of your magnetic storage type. So magnetic storage type mean in the simple way we can describe like that. These are the disk, means your hard disk is the type of magnetic storage media. Or your floppy disk, you might have seen the floppy disk. In earlier machine, the floppy disk was there. Or magnetic tapes also. These are the magnetic material, means the magnetic material is used here, and the disk moves. There is a circular motion to your secondary storage, that is the hard disk, as well as there is circular motion to your floppy disk. And as the disk moves, the head is there. So we can say that the head means there is a disk head, and that disk head will read whatever maybe the data is stored in the form of magnet in that particular magnetic disk. And the data is stored in the form of binary zeros and one on the secondary storage. That is nothing but your magnetic secondary storage media. Magnetic secondary storage. So these are nothing but your hard disk as well as the floppy disk. So what about optical storage? So optical storage in the sense that the optical storage media, information is stored and read using a laser beam. The important one, laser beam, just like it is nothing but your CD or DVD. So data is stored as a spiral pattern of the bits and ridges denoting binary 0 and binary 1. CDs and DVDs are the examples of your optical storage media. Right? So how the data is stored on the secondary media, So based on this, the two categories, magnetic storage as well as the optical storage. So in case of your magnetic storage, the data is stored in the on that particular magnetic disk. So disk moves, and the disk, there is a disk head that reads the data from that particular magnetic disk, and the data is stored in the form of zeros and ones, binary data. But here in case of your optical storage media, the laser beam reads that particular disk. So if you open your CD drive or your CD-ROM, you will find that there is one pointer pointing the laser beam. So when the CD rotates in the CD-ROM, then the laser pointer reads that particular CD or DVD. Accordingly, the data is getting read in that particular device. That is called as the optical storage device, right? The next point is that in the introduction of secondary memory, now we'll come to the hard disk. The major one can say that the very important secondary storage media is nothing but your hard disk, and we have to focus on this particular secondary storage media, that is nothing but your hard disk. A hard disk consists of one or more circular disks called platters, which are mounted on a common spindle. So each surface of a platter is coated with a magnetic material. So see here, so hard disk is nothing but, so see the structure, we have to see the structure of secondary storage, because in this particular unit we have to focus on this hard disk only. Though there are various secondary devices like your CD, DVD or pen drive, USB devices are there, secondary hard disks are also there, but we have to focus on the internal storage media, and that is nothing but your hard disk, because the huge storage space is provided by your hard disk. You can have 1 terabytes of memory or even more than that of is available with that particular internal storage media, that is nothing but hard disk. So we are basically focusing on the hard disk drive in the secondary storage memory, right? So hard disk, so how the hard disk is there? So hard disk, it is nothing but it consists of one or more circular disks called as a platters, which are mounted on a common spindle or common cylinder, you can see that. So each surface of a platter is coated with a magnetic material. So it is nothing but it is a magnetic type of disc. So each platter its plate is coated with a magnetic material. So on both the sides, so both surfaces of each disc are capable of storing the data. Means on the this, suppose if you can assume that this is the disc. So on this particular on the upper portion you can store the data, as well as on the portion which is below to that particular disc. So this is also where you can able to store the data on the lower portion of that particular disk, right? So data except the top and bottom disk, where the only inner surfaces are used. So we can have there is a concentric disk. So this arrangement of the secondary storage is like this. So this is nothing but the concentric disk. So this is disk number 1, disk number 2, disk number 3, disk number 4. So like this way it is, and these are mounted through your spindle, or it is called as a cylinder, right? On a concentric rings are there. These are the concentric ring. So both the portion, this portion as well as the below portion of the disc, it is used. But for the first as well as the last disc, only inner and the outer portion is used. In case of first as well as, so this is your first disc and this is your last disc, where the only outside portions are being used. The information is recorded on the surface of the rotating disc by magnetic read-write head, and there is a head which reads the information on each and every disc. So head is mounted to each and every disc. So there are a number of concentric discs, and to each disc there is a head. For each disc there is a separate head, and that head reads that the contents on that particular disc, magnetic disc. So these heads are joined to a common arm known as access arm. So these heads are joined to a common arm known as access arm, right? So most of the basic types of the hard disk contains a number of disk platters that are placed around a spindle, which is placed inside a sealed chamber. The chamber also includes read-write head and the motors. So data is stored on each of the disks in the arrangement of the concentric circles called as the tracks, which are divided further into the sectors. So basically, this particular disk, you say for example, this is one disk, or this is one diskette or one platter. One plate of the hard disk, it is divided into number of sectors, number of tracks. tracks means it is nothing but the concentric circles. So you can have the concentric circle, so that gives you the number of tracks, right? And sectors means these are further divided into the number of sectors. These are further divided into the number of sectors, right? So these are the tracks and sectors on a magnetic disc or a magnetic plate on both the side, the upper side as well as the bottom's lower side of that particular disc. So most of the basic types of the hard drives contains a number of these platters or the plates that are placed around a cylinder which is placed inside a sealed chamber that is called as a cylinder. And the chamber also includes the read-write head. The data is stored on each of the discs in the arrangement of the concentric circles called as the tracks, and these are further divided into the number of sectors. See here, right? So this is nothing but your disk arm. So this is nothing but this is your disk number 1. This is nothing but your disk number 2. So from the figure, it is clear to you that this is disk number 1, disk number 2, and this is the central cylinder, or this is the central cylinder. You can say this is the central cylinder. So okay, and this is the head. This is the head, and this is the disk arm. This is nothing but your arm for the head 1. This is the arm for the head 2. This is nothing but head 2, and this is nothing but your head 1. So this head. So actually while running condition, this discs are rotating with this particular cylinder or with this cylinder. Their motion in a circular motion. Their motion in a circular motion, and at the same time, this particular disc arm, it moves in back and forth direction. It moves in back as well as in forth direction, right? So there are two type of motion while this disc is in a working condition. These plates, this is nothing but your plate number 1 and plate number 2. The plates move in a circular fashion, but at the same time, this particular disc arm moves in the back and forth direction. This back and forth direction, this will move. And while moving the disc as well as this arm, the disc arm reads the data. This particular disc arm reads the data which is written on this particular magnetic surface. So this upper surface as well as the inner surface, it is coated with the magnetic material. That's why it is called as the magnetic disc. And this is concentric. They are again concentric. There are only 2 plates are shown in the figure. So like this way, there are multiple number of plates are there. So you can find like this. So there are, say for example, 9 to 10 plates are there, and there are 9 to 10. So for each plate, there is a separate head. For each plate, there is a separate head. So head moves in a back and forth direction, whereas this disc moves in a circular fashion. Right, so this is the figure. So you can just remember this, so that because depending upon this architecture, if this architecture is clear to you, we have to solve the number of problems based on this particular how to access the data from the secondary disk. So we have multiple number of algorithms like your FIFO, SSTF scan and C-scan algorithm that is totally based upon this particular architecture of the disk, right? See this, the hard disk is a memory storage device which look like this. So the concentric rings, so to this concentric ring, these are called as the tracks. These are called as the tracks, just like your running track. So if you see the ground of the Olympic running, so these are nothing but the circle, and there are concentric rings. There are concentric ring, and each ring is called as a track. So each individual runner, he has to run on this particular its own track, right? And further, these tracks are divided into the number of sectors. Further, these tracks are divided into the number of sectors. So each plate, so this is nothing but your plate number 1. Okay, this is nothing but your plate number 1 in that particular hard disk. So like this way, all the plates, suppose there are 4 to 5 plates, so all the plates, they are having the tracks and as well as the sector. Then what is the use of making the track and the sector? So use of the track and sector to store the data, because unless and until the disk, this magnetic material, it is divided into the number of tracks and the sector, we cannot store the material on that particular disk. So when you know the concept of disk formatting, when you format your hard disk, right? So before installing your Windows operating system, you need to format your secondary storage. You need to format your hard disk. So while formatting your hard disk, what actually done or what actually happened when you format your hard disk? So formatting your hard disk means creation of tracks as well as sector on your hard disk. You are going to create the tracks and sector, and you are creating the FAT table, that is file allocation table, FAT32, or you have NTFS, that is NTFS file system. NTFS means new technology file system, for and you have ext3 file system. If you want to install the Linux operating system, the file system type is extended 3. Means on this particular, when you are formatting, so this disk get formatted with the help of this extended 3 file system. When you want to install the Windows operating system, you can have NTFS as well as FAT32 file allocation table, 32-bit and NTFS new technology file system. These are the file system used for your Windows, whereas ext3 it is the file system used for the Linux operating system. So before installing the any operating system, you need to format this disk, secondary disk or the hard disk, with the help of this file system. So you are formatting the disk means you are creating the tracks, track and the sector in the particular fashion of FAT32 or NTFS or extended 3. So as soon as you format the disk in a particular fashion, then and then only you are able to install the operating system on that particular disk. Getting this point? So the disk is divided into the number of tracks. So each track is further divided into the number of sectors. The point to be noted here is that outer tracks are bigger in size than the inner track, but they contain the same number of sectors and have equal storage capacity. This is because the storage density is high in the sectors of the inner tracks, whereas the bits are sparsely arranged in the sectors of the outer track. So these are the tracks. So you can say these are the outer tracks, whereas the inner tracks are here. So inner tracks, they are having the densely storage data in case of your inner tracks, whereas in case of outer tracks, the data is sparsely distributed, means the density is low as compared to the inner track, right? So read-write head moves over the rotating disk. It is this read-write head that performs all the read and write operation on the disk, and hence the position of read-write head is of major concern. Means to read the data from this particular disk, you need this particular read-write head. This is called as a disk arm or the access arm, and this is the head. This particular head moves in the back and forth direction to read the data which is stored on the secondary storage or on this particular hard disk, right? Next point is some important terms must be noted here. Now see here, we have to study these important terms which are related with your hard disk or the secondary storage. Seek time, rotational latency, data transfer time, and the controller time, and the average access time. Because while studying the algorithm or while finding out the capacity of any storage media, these terminology are very important. Seek time, rotational latency, data transfer time, controller time, average access time. So, right. So seek time is what? The time taken by read-write head to reach the desired track from its current position, it is called as the seek time. Means if you want to read a particular information or if you want to read a particular byte, so current head position may be some at a different location. So the time taken by that particular read-write head to reach to the desired location, it is called as the seek time. This is called as the seek time. The rotational latency is nothing but the time taken by the sector to come under the read-write head. The time taken by that particular sector to come under the read-write head, it is called as the rotational latency. The data transfer time, the time taken to transfer the required amount of data, it depends upon the rotational speed. So your disk, they are moved in a particular RPM. There is RPM, means rotation per minute. So disks are moving with a certain speed, and it is called as the revolution per minute or the rotation per minute. So data transfer time, it is depending upon how fastly the disks are moved, So as you are increasing the rotation RPM, so definitely the data transfer time is less. Data transfer time will be less. Controller time, the processing time taken by that controller or the disk controller. Average access time. So average access time is nothing but the addition of seek time, average rotational latency, plus data transfer time plus the controller time. So addition of all this seek time, rotational latency, data transfer time, and the controller time. So adding all these four components, we are getting the average access time of that particular secondary storage device or of that particular hard disk. Getting this point? So again, see this seek time is nothing but the time taken. It is nothing but the time taken by the read-write head to reach to the desired track from its current location. Rotational latency is nothing but the time taken by a sector to come under the read-write head. The data transfer time is the time taken to transfer the required amount of data, and it depends upon the rotational speed, that is nothing but your RPM. The controller time is nothing but the time, the processing time taken by the controller, disk controller, and the average access time. Average access time of that particular disk you can calculate by adding the seek time plus average rotational latency plus data transfer time and the controller time. Now we'll see one example here so that the concept will more clear to you. For example, consider the hard disk. Now remember these figures. It has 4 surfaces. It has 64 tracks per surface. It has 128 sectors per track, and it has 256 bytes per sector. 4 surfaces means what? There are 2 disks. So this is surface number 1, and 2 is below surface number 2, and another disk is there. So it has surface number 3 and the surface number 4. Total number of disks, total number of plates are there. 2 plates are there having 4 surfaces, and each and if they contain what they contain? They contain 64 tracks. So they are having total 64 tracks per surface. On each surface there are 64 tracks. So you assume that there are 64 tracks on each surface, right? And there are 128 sectors per track. Per track there are how many sectors? You can find there are 128 sectors are there. 128 sectors per track. And in each sector, how many data bytes it is going to store? It is going to store 256 bytes per sector. It is going to store the 256 byte per sector. So consider the hard disk with 4 surfaces, 64 tracks per surface, 128 sectors per track, and 256 byte per sector. Now remember these figures or remember these numbers, because for all the next examples we need this data. So first example or the first numerical is what is the capacity of the hard disk. So we have to find out what exactly is the capacity of the disk. So disk capacity is given by surfaces multiplied by number of tracks per surface multiplied by sectors per track multiplied by bytes per sector. So we can have 4 into 64 into 128 into 256. So total 8 MB is the capacity of that hard disk. Multiplication of all this, right? So next is that the disk is rotating at a 3600 RPM, 3600 RPM revolution per minute, or what is the average access time? So here we have to find out the average access time. So see here, since the seek time, the controller time, and the amount of data to be transferred is not given, we consider all 3 terms as 0, because to find out your average access time, we need all the 4 terms. That is nothing but seek time, the controller time, as well as the average access time. So here these are not given, so we are considering it as a 0. Then therefore average access time is equal to average rotational delay. Rotational latency is equal to 60 seconds. That is nothing but your 3600 rotations. So 1 second is equal to 60 rotations. In 1 second, it gives you 60 rotations. So rotational latency is nothing but 1 by 60 seconds. That is nothing but 16.67 millisecond. 1 by 60, that is nothing but 16.67 millisecond. So average rotational latency calculated by 16.67 divided by 2 is equal to 8.33 milliseconds. So average access time is 8.33 milliseconds. So because here the seek time is not given, controller time and the amount of data transfer is not given, that's why they all are assumed to be 0. So 3600 RPM means what? 3600 RPM means rotational latency is given 3600 RPM. That is in 1 second, how many rotations are possible? In 1 second, there are 60 rotations are possible. So rotational latency is nothing but 1 by 60, that is nothing but 16.67, and divided by 2, it is nothing but 8.33 milliseconds. So average access time is nothing but 8.33 milliseconds. So the disk is rotating at the speed of 3600 RPM. What is the data transfer? Now here we have to find out the data transfer rate. So in the previous example, we have find out the average access time for the disk, but here we have to find out the data transfer rate. So how? So 60 seconds gives you the 3600 rotation. So 3600 RPM means these rotations are rotation per minute. So in a particular minute, how many seconds are there? There are 60 seconds per minute. So you can have 3600 rotation in 60 seconds or in 1 minute. Right. So in 1 second, how many rotations are there? In 1 second, there are 60 rotations. Getting this point, how the calculations are there? This 3600 RPM, revolution per minute or rotation per minute. And 1 minute contains how many seconds? 1 minute is nothing but your 60 seconds. So I can say that 3600 rotations in 60 seconds. So in 1 second, how many rotations are there? In 1 second, there are 60 rotations. Getting this example or not? In 1 second, there are total 60 rotations, right? This is clear. Now the data transfer rate is equal to number of rotations per second, that is nothing but 60, into track capacity into number of surfaces, right? So that is nothing but 60 into 128 into 256 and into 4. These are already given. 128 is given, 256 is given, and 4 it is already 4 surfaces are there. So the data transfer rate is nothing but 7.5 MB per second. 7.5 MB per second. Getting this point? So this is the way how if so there is any one numerical is there how to find out the disk capacity, hard disk capacity, the surfaces, track per surface, sector per track, and the bytes per sectors are given, and we have to find out the disk capacity in MB, right? So or if suppose RPM is given, so it is find out to disk transfer rate, or if suppose RPM is given, we can find out the average access time. So these are the 3 examples. You just remember it how to solve it. So RPM means what? Revolution per minute means 60 in a 60 second there are 3600 disk rotation. So in 1 second, how many disk rotation? There are 60 disk rotations in a 1 second. And if it is clear, then the next example is simple. We can easily solve the next part of that particular numerical, right? Okay. So the references for this unit, definitely we have to always use this reference book Galvin, or you can have the NPTEL video lectures also, and web resources are there. So there are some different web resources, or there are some different links I have given here. From that, geeksforgeeks.org is the new reference I have added in this particular unit, Introduction to Secondary Memory. So you'll find the very good information on this particular website, geeksforgeeks.org, Introduction to Secondary Memory. So, and this thing is very simple. There is no any critical part or no any difficult part is there. Though all the concepts are very simple. Geeks for geeks, hard disk drive, HDD secondary storage, right? So okay. So for the today's lecture, we'll stop here. So thank you, and tomorrow we'll continue the next part of the unit.